This is an example of how you do integration by parts. And integration by parts is one of those techniques of integration which you will find very helpful, especially in your study of physics. Now, I'm just going to tell you something which you probably have learned before, but is important that should be iterated about the LIATE. LIATE, where L stands for logarithmic, I stands for the inverse trig, A is for algebraic, T for trigonometric function, and X is for exponential function. This tells you of the order with which what part of the integral or the component of the integral will be taken as your u. Now recall from integration by parts that your integral will be re-expressed in terms of the integral of u dv. This is then telling you that you have to make a conscious choice of which to represent as u and which part of the integral will become dv, and that is very crucial in solving integrals using integration by parts. Now in this case, I'm just going to iterate. You express your integral in terms of integral of u dv, and then that is just equivalent to uv minus the integral of v du. Now we're going to apply what we mentioned. Notice that in our integral, we have in the order of the setting of u, the first priority is logarithm, and we notice that there is logarithm, in this case the natural logarithm or the ln of x. This is telling us clearly that our u, the priority for our u should be the ln x part of our integral. And once we have identified our u, this is just implying that, the derivative of u is simply, guess what? It's 1 over x. Okay? Now, once we have set our u, everything in the integral, I'm just going to shade this part. This one is our u, so everything that remains will become your dv. So we're set with u, so we're now going to check for dv. Now, dv, as I've said, is everything that remains. In this case, that's just x squared dx. Now, we're going to integrate that one because we want a v. So I'm going to integrate both sides, and I will get v is simply equal to x cubed all over 3. Now, why x cubed all over 3? I want you to recall this basic property or basic, I don't know how to call this, way of integrating x to the n dx. That is simply x, and then you add n plus 1 to the n plus 1, and then divide everything by n plus 1, and of course our integration constant c. Now if you're being OC about how I do things, notice that I should put c over here, but I'm not going to do that for simplicity, but I have it in mind that that should have a plus c, and that will come out later. Alright, so now that we have basically identified our u, just going to highlight this one because this is very important, our u and our v, I can now rewrite the integral above. So the integral above will be given by uv. Sorry. That integral above will just simply be this part, uv. So my u is the ln of x, and the v is x cubed all over 3. So I'm done with uv, and based from this, I should get negative of the integral of v. Now my v is x cubed over 3, and my du, based on how I solved it earlier, is just 1 over x. Alright. So now I'm just going to write this in this more friendly manner. I don't like seeing things like this. So this will become x cubed over 3 ln of x. And then this integral will further simplify into x cubed all over 3 dx. Right? X squared all over 3 dx. So I can further simplify this one because it's better if we simplify things prior to integration. I could just take out the constant, which is 1/3 in this case, and so I am left with x squared dx, a rather simple integral to do. So now our main concern is on how to deal with this one. But as I've said, this is just an application of your basic integration that you have probably learned. Now, in this case, I'm going to do the integral. So x cubed over 3 ln of x. And then notice that this will just become, I'm going to copy 1/3. And this part over here, if I'm going to apply this, is just x to the 2 plus 1. I'm applying this portion over here. And that will be divided by 2 plus 1. And of course, you have your plus c, the integration constant. Now, simplifying that further, I will get x cubed all over 3 ln of x minus 1/3, and everything in the bracket will be x cubed all over 3 plus c. Now, I want to simplify this further. I'm going to take out x cubed over 3, which is a common factor. So x cubed all over 3, what remains for the first term is simply ln of x. And then for this part, I will just have 1/3. And plus c. So there we go. We have solved this expression, this integral, using integration by parts by simply understanding that we have to use the LIATE as our means of knowing which part of the integral will be our priority for u. And once we are fixed with u, everything will just become dv. All right? So we have another example, a quite complex example than this one.